In this video, I'm going to show some extra practice for the Unit 3 Section 2 practice on covalent bonding. First, we'll go through a couple simple Lewis dot structures along with a reminder about how to draw Lewis dot structures and some general rules. We'll then look at some multiple central atom examples, some more complicated Lewis structures. And finally, there's one slide on some independent practice that you can do at your own pace. So let's talk about simple Lewis structures. First and foremost, don't forget that Lewis dot structures show that two-dimensional representation of how the atoms are covalently bonded. If, say, I have this carbon, these two hydrogens, and these two fluorines, a Lewis dot structure would show that the bonding is the carbon bonded to four outside atoms. Drawing Lewis dot structures, we have a couple of steps. If I have, say, my PCl3 here, my first step would be to draw the valence structure for each of the atoms solo. I can see phosphorus has 5, 1 pair and 3 singles. Each of the chlorines has 7, 3 pairs and 1 single each. My second step would be to choose my central atom, the atom with the most single electrons. Looking back, I can see that is my P for phosphorus. Put that right in the center. And finally, I'm going to place the other atoms around that central atom to create bonds between the single electrons. So I'll put my chlorines around, I'll arrange their electrons across from the phosphorus, and finally I'll redraw these single electrons facing each other with those straight lines as bonds. Again, these bonds represent both single electrons from each atom. Also notice that these pairs remain. Any pairs are going to remain exactly where they were to start. Before I head to some practice problems, know that there are two things we can predict from the valence structure of individual atoms. The first is that single electrons show how many of bonds an atom is going to end with when it's in the structure. And two, the paired electrons will not bond ever, but they must still be on the atom they started with in the final structure. So if I look at carbon, I can predict that because it has 4 single electrons, it should end with 4 bonds and no pairs of electrons. If you look at sulfur, it should have 2 pairs of electrons at the end and 2 bonds from its 2 single electrons. Bromine should end with 3 pairs of electrons and 1 bond from its 1 single electron. And hydrogen, one of our exceptions, because it has 1 single electron, hydrogen must form 1 bond, and that's it. Before we head on to our next part of the presentation, let's take a look at some practice problems. So if I head to this whiteboard, I can see that my first practice problem is CH2I2. In this problem, my first step would be to get my valence electron structure for each of these atoms. I'll draw carbon right here. Carbon has 4 electrons. I'll draw both my hydrogens. Pretty simply, each hydrogen should have 1 electron each. And then I'll draw my 2 iodines. My 2 iodines should have 7 electrons, and I'll do them around the outside. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So notice that carbon in the top left should make 4 single bonds. The 2 hydrogens in the top right should make 1 single bond each. And my 2 iodines in the bottom right should make 1 bond each and remain with 3 pairs of electrons. So if I scroll down just a little bit, I'm going to choose my central atom. In this case, I'm going to choose carbon because it has the most single electrons. So let's take carbon and put it right in the center there with its 4 single electrons. I'll start placing some of my other atoms around the outside. Let's take hydrogen, place it with single electrons facing. Another hydrogen over here with its single electron facing. Another hydrogen right here with its single electron facing. Oh, wait, we don't have 3 hydrogens. I need to take an iodine and have it face the carbon. And I'm going to rearrange its Lewis structure so that the single electron faces the single electron of the carbon. And I'll take my final iodine and again place that single electron facing the single electron of the carbon. Finally, we just have to connect our single electrons with our lines, our bonds, and that is the structure of CH2I2. Everything I'm boxing right here. Let's do another example below. We're going to do NH3. This one's going to be very, very similar. But for NH3, we'll start by drawing our N. We should have 5 electrons around N. 1, 2, 3, 4, 5. And my 3 hydrogens will all look very similar. And each hydrogen has 1. So this one should be pretty simple. We'll choose a central atom. We're going to choose N because it has the most single electrons. Scroll down a little bit, give myself some space. So N, I'll put in the center, and I'll put its structure on the outside. And I will just simply line up my hydrogens so that their single electrons face the nitrogen. Finally, I'll connect my single electrons with bonds, and that is really it for that nitrogen and 3 hydrogens. Notice that that single electron, or that pair of electrons on the top, remains in the final structure. Now let's look at a slightly more difficult molecule, CSO. You'll see that the same process can be used as what we used in the past. I'll start by drawing my Lewis dot structures for each of my atoms. Carbon should have 4 around the outside. Sulfur is going to have 6 total around the outside. Looks like 2 pairs and 2 singles. And oxygen will also have 6, 2 singles and 2 pairs. So when I'm choosing my central atom, I'm going to do this a little bit below. When I'm choosing my central atom, I will first choose carbon because it has the most single electrons. Put that in the center. It doesn't really matter which we start with, but I'm going to attach sulfur off to the right. I will line up the 1 single electron, and I'll just put my other single electron on the bottom. Doesn't really matter where you put it for now. And I'll put my pairs on the top and the right. Oxygen, I'll put on the other side of carbon, my central atom. Line up 1 single electron, and then the other pairs and single electron, I'll put around the outside. First thing we want to do is connect our atoms together. Now notice our structure is not complete yet. We still have single electrons left over that we need to bond. I can form a double bond between carbon and sulfur here, but now it seems like I'm at a stopping point. I have to do something about this single electron on the oxygen and this single electron on the carbon. Now, I didn't line them up in my drawing, but that's not a problem. I can rearrange where the structure, where the Lewis dots are. In this case, I'm going to switch the spot in the oxygen. Let me redraw the oxygen real quick. I'm going to switch the spot of the pair and the single. And this allows me to form that double bond right up there at the top. So why is this helpful? Well, now I can see my structure. If I give myself a little space at the right, and maybe I redraw this to make it look a little bit better, I can redraw this structure so that the double bonds simply look nice. Oxygen double bonded to a carbon, which is in turn double bonded to a sulfur. Then just make sure those pairs of electrons on oxygen and sulfur make their way into the final structure. All right, let's head back to our presentation and talk a little bit about multiple central atoms and how we deal with that. If I head back here, when we have multiple central atoms in our Lewis dot structure, we kind of have to add on one rule. If we have a situation like this where we have multiple atoms that can form the same number of bonds, we want to connect all of our central atoms first before attaching atoms around the outside. So for this C2H6 molecule, both of these carbons can bond in many different places. They have 4 bonds each. So they will both be central atoms. If I take kind of my pieces here of my Lewis dot structure, I'll start by putting my carbons in the center and bonding those central carbons. I'll then arrange my hydrogens around the outside, and it becomes very easy with this structure to see that each of the hydrogens takes up 1 more of those electrons. So we form bonds between the carbons and the hydrogens. We'll see some examples that are a little bit tougher than this in just a moment. Heading back to our whiteboard, I can see that my next example is C2H6. So for this example, let's get our pieces together. I have, let's see, 2 carbons, 6 hydrogens. So we got a lot of pieces here. So here are my 6 hydrogens right over here. And let's add our 1 oxygen down here by the carbons. Luckily, this seems like a lot of work, but once you have one atom of each element, you can see what the structure is for each. The carbons will have 4 electrons each, all single. The hydrogens will have 1 electron each, obviously single. And the oxygen should have 6 total electrons. So now that I have all my pieces, I have to decide what my center atoms are. I should probably put both of these carbons in the center to start. And I'm going to do this down below. Let's go down here. So if I go below kind of all those pieces, I'm going to take my carbons and put them in the center first, and I will bond those. So my whiteboard wasn't happy with that. There's my 2 carbons. I will connect them once. Now notice, if I arranged my hydrogens around the outside here, if I put my 6 hydrogens at all these spots, touch that up a little bit. If I put my 6 hydrogens all around the outside here, I would basically complete my molecule. If I did this and bonded my 6 hydrogens, my molecule would be complete, but I would still have this oxygen that I would have to deal with. So instead of filling up the spots with hydrogen, it's probably going to be helpful to attach the oxygen first. In fact, let's go ahead and erase this hydrogen, head back to our carbon, we'll open it up there. I'm going to bring this oxygen a little bit closer. Let's go ahead and redraw the oxygen off towards the carbon. I'll place its single electron facing the carbon. I'll put the other electron down at the bottom and place the pairs back on the oxygen. If I pair the oxygen here, I can see I have that one single electron left for my final hydrogen. So I can connect that. And now we have a molecule where everything is connected. There are no single electrons left. Let's erase this one by hydrogen. That was not an electron. And we have all of the pairs, the pairs on oxygen, we have all the pairs showing. So that's my final Lewis dot structure. Let's take what might be a slightly more difficult or maybe even slightly more easy example down below with C2H4O2. Same steps as before. Let's get our pieces together. Carbon with 4, and we've got 2 of them. We have 4 hydrogens. Taking a little bit longer to load. And my 2 oxygens. Let's draw that last oxygen in there. Okay. So we have all our pieces now. Obviously, our 2 carbons are going to go in the center. And let's do this in the bottom left here. I'll connect my carbons first. I'll now start placing my atoms around the outside. Because I have these 2 oxygens, they're probably going to have to form some bonds of their own. So let's place this first oxygen over here to the right and make a bond. So we now have one of our oxygens figured out. Let's go ahead and place our other oxygen, why not, on the other side. So if I go towards, let's go on the carbon on the left, I'm going to place the oxygen right on the other side. There, it's loaded. I'll bond once. And now notice I have 6 spots open, but only 4 hydrogens. Let's go ahead and take the hydrogens and place them in our 4 spots. Doesn't really matter where you choose at this point. I'll put 1 on this oxygen. I'm going to go ahead and put 1 on the second oxygen, or on the second carbon, rather. I'll put 1 on the third carbon, or rather the third atom in the chain, which is a carbon. And let's go ahead and we'll divvy it up evenly. We'll put 1 more hydrogen over here, attached to my last oxygen. Notice I can't be finished just yet because I still have single electrons. But to fix that, I'm just going to bond those 2 carbons together, like so. And I'll redraw it so that that bond looks nice and neat instead of being a longer bond on the outside. And there is my final structure for C2H4O2. The last part of this presentation, I'm going to show. We'll skip this slide because we already went over it. Go ahead and self-test. You want to pause the video now as you try to make the valence structures for H2O, CO2, and CH3N. I'm now going to reveal the Lewis dot structures of just the atoms. Those are the atoms for each of our 3 compounds. If you need to, pause the video again as you make Lewis dot structures for these 3 compounds. And here are the 3 compounds. I hope this helped you learn how to draw Lewis dot structures for some simple compounds.